Yeah, you guys have snow up there?
Yeah.
Well, yeah, like mild, like a little bit of snowing.
No, it's snowing pretty hard.
Oh, really? And you guys are still in school though, right?
Yeah, it started like an hour ago.
Yeah. We got just barely some flakes, and then it seemed to stop. How did the test seem the other day?
You want to take that one? It was okay.
Yeah. Yeah. Okay. Are you guys getting ready to go into exams at your school as well?
Yeah, they
Our
start
first one's
tomorrow.
tomorrow.
Oh, they start tomorrow. So when do they end? Friday and then Monday, Tuesday?
Monday, Tuesday, Wednesday, Thursday.
Oh, wow. Okay, so you have 5. And do you tend to have 5 exams?
Usually.
Yeah.
Sometimes it's
And-
6.
And will you take
I only
mine
have
on?
4.
Will you take mine on your science day?
No.
On the foreign language day, because we're both not taking a language.
Oh,
And that's the
okay.
day you have it scheduled for anyway.
So what day is that? Tuesday or
Wednesday.
Wednesday? Okay.
It's on the day that you would have planned.
Okay.
I'll have a history exam, then you're really happy.
So our kids have it a little easy in that this time of year they only have typically 3 exams: math, science, language. And we moved our humanities exams till March, so that splits things up a little bit.
Yeah. That's interesting. I've never heard that way.
Yeah, now they have that.
Like, this is our
Yeah.
midterms, and then we have finals.
Except
Yeah.
seniors, if they have
Seniors don't have finals.
Right.
If they
right.
don't have to see, they don't have a final.
Yeah, so it's pretty much the same, except we split it, so it's kind of been interesting. I think it makes exams a little less stressful not having to take 5.
It could go either way.
Yeah.
I'd rather have exams before winter break with less material than before spring break with more material.
Yeah. So Kira's not feeling well. I don't know if she's going to make it or not. I see she's she's signed in to class, but I can't see her yet. Oh, let me zoom in a little bit. What are you guys doing second semester when you're not in my class?
Nothing.
I'm taking an art class because I have to.
Same.
Okay. That'll be fun.
Eh.
Yeah.
I'm used to.
Photography. I'm actually used to having a science as my elective.
I'm like in 5 science classes right now. It's gonna be weird.
Wow. What's your other science, Summer?
I'm in AP Bio, Forensics, Anatomy and Physiology,
And then this
and I
one.
think and then this
And then
one.
Cal.
And then there's Cal.
Wow. Yeah, that is a lot of science.
And then lit.
Hi, Kira.
Hi.
Sorry you're not feeling
Well, at
well.
least it's good news. She's not wearing a mask. She's not dead. Yeah.
What?
Sorry you're not feeling well.
Oh, thanks. I thought some of them.
I said it's good news that you're not wearing your little mask, so maybe it's not that bad of a sickness.
They made me wear it on Monday.
Yeah.
Oh. Well, at least you're getting better.
Yeah.
Kira, do you have a snow day today?
I had a snow day yesterday,
Oh,
and then
yesterday.
today I had a relapse after first block.
Yeah, so you got sick and went home?
Yeah.
Well, I'm sorry you're feeling poorly.
We're gonna do a general review today, correct?
Yeah.
Okay. Thanks.
Yeah. You can just kind of relax a little bit, and if you have your textbook, it might be easier than reading I don't know how easy people can read the print on the screen when I cut it from the textbook, but we're going to go over some problems from, earlier chapters and just do some review for the exam today. Kira, what day of the week are you taking the exam next week?
I thought I was supposed to take it tomorrow.
That's the test. I'm thinking about
the exam.
Yeah.
Tuesday.
Tuesday. And do you have other exams you're taking as well?
Just papers, no exams.
Okay. All right. Good. Good luck with things.
Actually, yeah.
Yeah. And what are you doing second semester when you're not in this class?
I'm actually gonna start linear algebra independently. I'm not gonna do another Malone course.
Yeah. Hey, I see there's one student from your school that's gonna be taking my class next semester.
Cool. Who?
I've forgotten her name because I don't know my class well yet. Let me undo this so it doesn't show, and then I'll try to pull it up. Let's see if I can find it real quickly. Here we go. Olivia Shepard.
Yeah, she's awesome.
Yay.
Very good at biology and sciences. We did AP Chem last year together.
Oh, cool. All right, great.
She shares your sense of humor.
All right, that'll be great. Excellent. Is anybody doing anything fun over the winter break? Summer?
I'm going to Italy.
Oh, that's great. Nice. Summer, what are you up to?
Never mind.
We're going to Italy in spring break. So.
Well, you were going to say something before.
We're going to Italy during spring break. That's why we were like over the top.
That's nice. That's nice. Is that with your school or?
Yeah.
Oh, cool. What part of Italy?
Milan, Florence, Rome, Venice,
Brescia.
and Brescia.
What was the last one?
Brescia. It's like, it's close to Milan.
Okay.
Okay. Nice. My family's from the south, other than some relatives in Switzerland, so that's really where I'm going.
You should visit Robin!
Yeah, right?
Wrong side of Switzerland. They're the best side.
I think you're getting emails for your next semester class.
Oh, and you're not in.
I'm in.
Do you guys study Italian?
You have a test.
Just reply that I'm not in the class. That way
We study Spanish.
I haven't graded.
That's
Or
close
study.
enough.
I want to know if I failed or aced.
I also know Arabic, so maybe that'll help a little bit.
Cool.
Go either way.
Yeah.
Speak Arabic for them.
Do you know how hard that is?
No.
No, like I can't just randomly just start saying words in Arabic.
I can say apple.
There's a growing Arab community in Rome.
Yeah, that's why I was like, oh my god.
Hi, Margaret.
You should visit them and see if anything works. Hi, Margaret.
Too bad I don't know anyone in Italy.
I'm gonna sit here and tell her to say words in Arabic for me now.
I'll send you to my uncle Marco. Actually, he's a creep. Don't. Yeah.
Oh my god.
Sorry, that's my only relative in Rome.
Oh, good. I tell you to visit my relatives in Syria, but that's not a move right now. So,
No.
you know, that's not gonna happen.
We have a new student joining us today.
So I took about 3 months of Orgo, but I kind of need to be reversed. Hi, guys.
We have a new student joining us today.
My name's Franz.
Yeah, Franz.
Are you gonna take the final exam?
Got to take the final exam with just 2 days of review is all you get to help you out.
All right, well, I'm going to leave you guys to your work.
All right, good luck, Franz.
Yes. Right now, there's only 4 others, but I think it's 11. How many kids are in the class?
10.
11? 10?
Oh, your kitty cat's behind you. Kira,
Look.
Kira, your kitty cat's getting ready to. She's coming down the stairs. Yay!
Kira is constantly.
Yeah. Hold on.
Guys, Evelyn Gray won Gatorade Player of the Year for DC for volleyball.
No way.
That's insane. Really? Yeah. Holy crap. Wow. That's absurd. As a sophomore?
Wow.
No.
Have you seen her volleyball games?
Oh yeah. Oh no.
She gets
She's
more than
unbelievable.
half of our points.
She's
all the time.
unbelievable.
Yeah, consistently.
But I'm not saying she doesn't deserve. Like it's. I mean, it's still just crazy.
That's a big deal.
All right, I've got 2:15, so let's get settled in here. Margaret, you what day are you planning to take the exam next week?
Mr. Walker, I told Mr. Armstrong I'm going to take it Monday.
Yeah, I got that.
Sorry. Okay. I'm planning on taking it Friday.
Friday, okay.
What's the day off?
Hey,
The
Keith.
language day.
You have
I'm planning to
Wednesdays
take
when
whatever that
you're
is.
taking.
Yeah.
You and Max are taking Wednesday. Hi, Keith.
I am Max, but.
It's Cairo.
Keith, you're all dressed up today.
Yeah, we had a dress up day for our Christmas travel.
Nice, looking good. Keith, what day are you taking the exam next week?
I'm pretty sure I'm taking it on Thursday. Let me check real quick.
Can we learn how tall everybody is today?
Yeah.
Yes.
I'm gonna ask for questions.
Do you know your guys' heights in case like it doesn't clear?
Yeah, I'm pretty sure.
I know my height. I've actually grown.
So that's the problem.
Nice to have your kitty cat in class today.
She really likes chemistry.
Yeah, chemistry rocks. So I think I know when everybody's taking the exam so far. We still don't have Peter logged in yet, or Robin that I can tell. How did people feel the test went the other day?
I felt swimmingly well.
I
I don't even know if that's like a
Oh yeah, Kira hadn't taken it, so don't say anything like, "Oh yeah, question 4 was no."
But question 3 is 3 for answers.
Hey, Mr. Walker, like, we were going over the test answers today in class.
Yeah. All right. Let's see. So I still don't have Peter or Robin. Let me go on and. Oh, what happened to my screen here? Where'd my Adobe? There it is.
3 months was long.
All right. Let me make Keith a participant or a
For some reason,
presenter.
right now, Adobe Connect is taking forever to load. I'm like trying to get in, but
All
having some
right.
trouble right now.
No problem. All right. Everybody's now a presenter, and I'm gonna stay as host and not try to give that up this time.
If anybody else wants to be host, you're welcome.
Max has got a quick question for the class, just as we are sort of getting ready to get going, and also it's a little bit of a stall tactic on my part for waiting for Robin and Peter. Max?
I'm very curious because like when you're in class with everybody, like you're next to them, you get to see how tall they are. How tall? Can we go around and take guesses at how tall everybody is?
Yes,
And then learn how tall everybody actually is.
All right,
because I'm
so here's the
very
way.
intrigued.
Here's the way we're gonna play the game. I'll participate. Write down everybody's name, and beside him, write down what you think the height is. Then we'll get everybody to tell us what their height is, and then we do a difference bar in inches, like how far off we were. Then we'll do we'll sum that up and see who gets the most points, or your goal is to get as close as possible. So write down your height, and then yeah, well, most of them have their names up on the screen, but write down everybody's name and what you think their height is. It's a guessing game, and yell out if you need help with someone's name or anything else. And we have to add Robin and Peter, who aren't here.
Robins, you have to do in meters.
Convert to feet, Robin. Convert.
All right, I will play in the game too.
It's good practice for dimensional analysis. We have that, right?
I know, right? We do. All right,
Wait,
Margaret.
how many people do we have?
We have 10 people.
Hey, Max, how tall are you?
Opt out of this and go get food instead.
It'll only take 2 minutes, ish. Summer, Marcel, Margaret.
Oh, we were missing Peter.
Peter, Robin.
Peter's a short stack.
Okay, I won't take
looks
2
like
minutes. I'll
Robin
be
just
right back.
logged in. Kira.
Is there a
Max.
prize for getting the closest guess?
Is there what? A prize? Of course there's a prize.
Microphone!
Can you give us
Ramsey.
5 extra points on every test we've taken?
Oh my gosh, if that's the case, oh my god.
I worried people would cheat then. So let's keep it honest.
Facebook, here I
Not
come.
make it too
Who am I for?
Max, Ramsey,
Who am
Younghyun.
I forgetting?
Micro points if you can spell my name right. Oh
2,
crap,
3,
it's
4,
in
5,
Adobe.
6, 7, 8, 9, 10. All right, here's the list.
Whose?
Robin and Peter, if you joined us late, what we're doing is writing down everybody's name and guessing their height, and writing what you think their height is. Then we'll ask for their real height. As long as people are willing to participate and give it. If they're not, then we'll just exclude them from the list and keep going.
Oh, and I gotta guess.
And then if you can sum up how far off you got from each person. Like if you're an inch or two away, write that down. Then we'll sum up how far we off, and we'll see who got the closest in our game. This is Max's question of how tall everybody is. Class list: Peter, Robin, Keith, Margaret, Marcel, Summer, Kira, Max, Ramsey, and Younghyun.
And Mr. Walker.
And Mr. Walker. Okay.
So you're supposed to write everyone's name down and guess their height.
Yeah. Who is that?
Who is that?
That's a voice we don't recognize.
Tech guy from Peter's.
That's tech guy from Peter's school. Okay.
High tech guy from Peter's school.
Kind of sounds like Mr. Helmet.
He did.
You give like a 2-inch range.
Quickly, Peter's standing up. Peter's standing up. Standing up. Oh!
Peter, we almost
kinda
guessed your height
second-guessing
because you were standing up for a second
I'm
there.
kind of second guessing my thing with Peter. He looks taller.
It's just the camera, don't worry.
Yeah.
I'm not telling you. I actually
Mr.
I
Walker?
have a hard time with
Yeah.
Young too.
Just one question. I'm not sure. I'm not so good in feet, sort of. So I'll just guess it in meters. Is that all right? As well?
Well, when you weren't here, we said you'd know it in meters. Then
You have to convert to feet.
you have to
It's good
convert to
practice.
feet and then inches. So,
Okay, I'll try that.
Peter,
You guess in
need to...
centimeters, you're gonna be closer or farther than everyone else.
Exactly.
Yep.
Peter, you're trying to guess everybody's height in class. It's a little game to warm up.
But I see your ID. I just want to make sure.
Yeah.
I just want to make sure you are Mr. Walker and you're not some like.
And then people will tell us
Alright,
their
here's the
height. And
deal.
we'll see how close
1
we
meter
got.
is 3.28 feet. So
All right, thank you.
I had to check my ID to make sure.
I'm gonna guess Peter on.
I have no clue.
Yeah, I could be. Keith is an anomaly.
Yeah.
Keith can either be like
Maybe,
6'2" to 5'8".
Can you maybe turn off the presentation on so that Peter has a chance to see anyone but like everyone besides just the last person who's spoken?
Yeah, if I knew how to turn off presentation, that would be good.
Are you sure that's not Mr. Hammond's twin brother?
Yeah. Yeah, I don't know how to turn off presentation. I don't think.
Well, I think it's something that has to do with this, but we can see it. Like we can see everybody. So I don't know if.
Yeah, Keith, can you say something loud and maybe that'll throw you to a bigger screen? There you go, Keith.
ooh, that was very loud.
Full blown now. All right.
All we can really see is Murray.
Oh, really? That's odd. Yeah, we can see everybody.
Very small in the top left corner.
Huh.
That's.
Yeah, I don't know how to change that because we're. Okay.
Gotta be
Does everybody
setting,
have-
I think that's a setting that they need to change, not you.
I think so too. I think everybody else can see everybody else okay except for
Yeah, there's a slider at the
Peter's
bottom
screen.
of the blue jeans thing that allows you to go between presentations and people. So maybe if their slider is all the way on the right, that might be the problem.
Oh, thank you.
Yeah, we're not using the Blue Jeans browser interface. We're actually using a teleconferencing box, and it seems to behave differently than all the other ones.
Okay.
So yeah,
Sorry
what we see
about
right
that.
now is primarily an OSX screen that says Intro to Organic Chemistry, Thursday, sharing, and then in the top left corner we just see whoever the most recent speaker in kind of a small picture.
That's weird. So it's seeing this big
Using
and
Blue
that
Jeans, you have
small.
3 options for displaying the
They're not
people.
using.
Yeah, they're not in blue jeans. Thanks, though, Kira.
That's weird.
Yeah, I think that's going to help get somebody that knows more tech than me to try to help with that.
Yeah, we've been talking with Greg over at Stanford all semester, and we're hoping to figure it out.
Okay, yeah. All right, thank you. All right, let's go down the list. Hopefully people have written down their guess for heights, and beside it, you can see how close you got, and then maybe just put a plus or minus. So this is an absolute value. Like if someone's 5'6" and you thought they were 5'8", that's 2 inches away. All right, Peter, do you mind sharing your height?
5'10".
Whoa, nice.
No.
All right, good job.
Damn it.
Thank you.
I said you
Some
were,
people are way off. All right.
I said you were 5'4".
All right,
my
Robin. This is going to be tough. Robin, in Switzerland, what are you in as best you think you are in terms of whatever? Tell us and we'll do some conversions.
In terms of feet, I think 5'6".
Whoa!
I nailed it. That's
I said 6.
Take that!
Nice, thank you. Keith.
Oh, here we go.
I'm about 5'10".
Nice, John! Oh, I got you.
I said
Damn
5'11".
it.
I pegged you. All right, perfect. Margaret, do you mind sharing?
Are you sure you didn't have access to all this information?
No,
I
do
think
not.
I'm not totally sure. I think the last time I measured myself, I was either like 5'5" or 5'4", maybe.
Say 5'5". Say 5'5".
Five.
Can you just say 5'3" for me?
We just
please,
locked in
Margaret?
5'5". All right. Marcel, do you mind sharing your height?
I'm 5'6".
Oh!
Yes!
All right.
I said all those people were tall.
All right.
You guys gotta grow.
Summer, do you mind sharing your
Marcel
height?
said she's 5'6".
Yeah.
Marcel says she's 5'6". Summer, do you mind sharing?
I am also 5'6".
Oh,
Damn.
nice. All right. Kira, do you mind sharing your height?
5'5".
Oh,
No, I said 5. I said flat 5.
All right, good
What
job.
the heck?
Okay, here we go. We can't tell from this screen. All right, Max, what are you? Do you mind sharing?
I'm 6'2".
Oh, dead on.
Crap, I said you were like. I
Wait,
said you were,
what?
Oh wait, actually.
6'2". He's our basketball player.
You're kidding me.
How tall did you think I was, Kira?
Frankly, only about 5'2".
What? Wait, Max Stein.
Wait, stand up beside me, Max. Go. Stand up. I'm standing full height. Not really.
You don't look that tall next to the whiteboard, in all fairness.
That's a window shade. That's why.
Okay. Ramsey, do you mind sharing your height?
I'm like 5'5.5".
5'5.5". Oh, wow. That's a tough one. I got blasted
who
on
is
that
this?
one.
Ramsey.
Ramsey's
Oh.
5'5.5". I just got blown away on that one. All right, Yan.
5'9".
Woo! All right, 5'9". I'm one off. Mr. Walker. Oh, I'm 5'11".
No.
You're, wow, I'm 1 foot off exactly.
What foot?
5 feet? Or
What am I, like a midget?
6'11" or 4'11"?
Right?
Nick,
All
Kira,
right.
how tall are you?
The smaller one.
That's okay. So now take your difference in inches, add them up, and we see who gets it. Kira is 5'5".
Okay, I thought you said 4'11".
So see how many total inches off you were.
I'm 22 inches off.
Oh
wow.
my god.
Robin killed me.
Wait,
I was thinking Robin was
excuse
tall.
me?
I gave him 6 feet, and I thought he was going to be tall.
I'm 14.5 inches off for the whole
I'm
class.
still adding up.
Well, actually, I'm 21 and a half off.
More than that off, so I'm off the
Wait, are we taking the averages of how
No,
wrong
no.
we were?
No, we're going to add up all the differences. So if we're 2 inches off, and then 4 inches off, and then 10 inches off, we'll just add up all those.
One that was correct.
I had 1. I got Marcel right.
I got 4. Well,
I
counting
got
myself.
3 that were right.
I got 2 right.
Yeah.
You threw me off. I thought you were 5'4". That's not fair.
That's your fault, man.
Oh, nice recovery.
Robin crushed. I thought Robin would have been over 6 feet. I need a conversion check on that one.
All right.
I need a recount.
Keith,
Robin.
how did you do?
I was about 19 off, exactly.
Okay.
23.
I think I may have captured that one, unless someone can be 14 and a
You
half
want to get a
inches
smaller
off.
number.
Yeah, you want the smallest number.
I know.
I was gonna make sure you knew.
I think Kira might take the prize for the highest number.
Kira's got a
Excuse
combined
me?
24 inches right here.
Kira, you need a calculator to add up all your numbers.
No, I don't.
Okay.
I'm 32.5 off.
Oh my god.
That's not that bad. Okay, let's get down to business
And
then.
that's because I got 3 right, and then Mr. Walker and Max are just, like, totally misrepresenting their heights on camera.
I think it might be the table because the camera's closer to this end of the table than it is that end.
Oh, yeah.
I guess that's true.
It's funny how, yeah, you have no sense. All right, Max, thanks. That was a good game to play.
Everything.
All right. So let's talk about the exam. I think it's clear from what I've said by email and other, but just to be hopefully perfectly clear. So it's chapters 1 through 7. I tried to equally weight it so that, as much as possible, it's not like, there's tons of questions from the hardest chapter, which I think might be 5 or maybe 7, and then less from others. So hopefully, also the questions, I think almost 100%, if not 98%, are questions that you have access to. In other words, they're questions from the back of our book. So they are, ones that either have been assigned for homework already or the ones that weren't assigned that are pretty much very similar and extra practice for. So what we can use today and Monday to do is practice anything you want. I've loaded up a bunch of questions from the textbook that we can go through. For some of this stuff, it's been a while since we've talked about it. For other things, we almost have been reviewing it constantly because it's always been used. Max, question, or anyone else? Go ahead, Max.
I think it was Unit 5 where we had the kind of 2-section test. Do we have to re-memorize all those reactions?
No. So thank you. You don't have to re-memorize those reactions, and you'll be given all those reactions. I think it's 3 pages worth of reactions and a page of the whatever you call it, the benzene ring substituted compounds. So in terms of memorization, I think there may be a couple reactions, 3 or 4 in chapter 4 that you'd want to know, but other than that, I think everything else is just going to come down to things that you've learned that aren't a whole lot of memorization about at least reaction types. So
do we have to know? I'm assuming chapter 4 you're referencing the stuff that like the ones that produced cis and produced trans.
One produced cis and one produced trans, for example. Yeah.
Yeah, the like Linlar.
The Linlar reagent and then the lithium. So. Yeah, but they're given to you on that sheet. Both alkylation and acylation are given to you in the chapter 5 reactions. So look at the chapter 5 reactions and see that most of that is given to you because it's there. So good question, Max. Other questions about the exam itself? It's written to be about 2-ish hours. Some of you take tests faster than others, so I think the range will probably be from 1 hour and 15 minutes to 2 hours and 30 minutes is my guess, because again, some of you are just really fast and some of you take a little more process time, which is fine. So in terms of any scheduling or things like that, I tried to write it for 2 or a little less than 2. Anything that you guys, I don't know where you are with study. As I talked to some people, I was asking them about their exam week. I assume most of you have other exams you're taking this time of year. And I've talked to most of you about what day you're taking it. I didn't get that answer from Peter or Robin because you guys came in a little later. So you guys at some point maybe can yell it out. Or any questions before I just jump in or anything else?
Can I take it Monday?
Yeah, actually, Peter, I did know that. You'd already told me that. Thank you. I just wrote that down for myself. Yeah. All right, so let's jump in. I've loaded up some slides, and I've got a bunch of them from Chapter 1. Also, I'm okay with, hearing from you guys, oh yeah, we're good on that. There's no need to review it. So it could be we don't need a lot of review from some of the earlier units. So some of these first questions here, can people see them okay? And if you can, I'd encourage you to maybe open your textbook, because all I'm going to be doing is going to the end of each chapter and pulling up various problems.
Oh, before I forget, Ramsey and I had to tell you that we're on the email list for your second semester class, and we're not in it.
Oh, so just email back that you're not in it.
Okay, yeah, I just wanted to tell you in person.
I think he told me that too. So are you in my second semester class?
No.
No one is? I have no Murray people in my second semester class?
Not this room.
Yeah, that could be.
I don't think there's anyone else. Okay, so the first part here just goes into Lewis dot structure. Are there any electrons missing in any of the molecules shown? Let's see, for some reason my green pointer arrow is not letting me play the game here. Oh, there it is. Somebody probably pulled it and is helping me out here. Okay, so we could either add electrons as needed where they're missing. So I'm gonna assume that this is okay, because we've been doing this all semester and probably pretty good. And I'll forward on unless someone says or has a question about something. So formal charge, this is something that might need a little review. We haven't talked about formal charge for a little while. Can anyone remind us how you do formal charge? Like if we were looking at, wow, I just am having trouble moving that. Can someone move there? Thank you. How would we determine the formal charge, let's say, on this carbon that I'm pointing to? Or can someone yell out the formal charge, either one? Margaret, help us out.
Okay, so you calculate formal charge by counting the number of electrons where, say, any bond that you have, like the carbon has a triple bond to the end, so that's going to be 1 electron for each of those bonds, plus the 2 lone pairs gives you 5 electrons on carbon, and you compare that to the number of valence electrons that it has normally, which would be 4, I think, so the formal charge on carbon is -1 because it has 1 more than its usual.
Excellent, correct. And the nitrogen should normally have 5, and in this case has 5, so it's got a 0 formal charge. All right, good. Anybody need any more review on that?
Is a -1 formal charge or a +1 formal charge favored, or are they both?
Good question. Who can answer Max's question? If something has a negative formal charge or a positive formal charge, is one favored over the other? Ramsey.
I think if I recall correctly, negative formal charge is favored on things that want more electrons than normally have. So like a bromine with a negative formal charge is correct, but a carbon with a negative formal charge, probably not so much.
Everybody hear Ramsey okay?
And like sodium with a negative formal charge, like.
Yeah, good. You want to minimize formal charge, but if it does exist, it'd be better if it's negative on something electronegative like oxygen, or if it's positive on something electropositive, maybe like a carbon, something with a lower electronegativity. Good. Okay, then there's resonance, where electrons can swing around. We've been doing a lot with resonance, so I would anticipate that hopefully you feel pretty confident about resonance. And if you saw a question like this now, you'd be like, I'm good for this. Because we've been doing a lot with that. So if you have questions on it or anything, actually, feel free to email me. But I'm going to assume we're probably pretty good on resonance. So let's keep going. The next thing might be shape, what's the bond angle around something. So you might want to, might need to review that. So let's take something like, let's point to this nitrogen right here. There's a bond angle, there's a carbon to its left, and there's a nitrogen to its right. Let's all try to think about what the bond angle for this thing is, and then we'll yell it out in a second. So, or somebody can raise their hand and give it to us. Who wants to do this one? Peter?
Is it like less than 109.7?
What you mean is 109.5, but I think it's a different answer than that. Max?
I believe it's 120 and bent.
Yeah, it's a little less than 120, and if you were given the shape, it's bent. So, Peter, your answer would be right if we were talking about the bond angle around this nitrogen, because then it's got a single bond, single bond, single bond lone pair. So yeah, that would be correct. Let's see if we can find, how about this sulfur right here? So notice that it's got a carbon to its left and a sulfur to its right. And there's some stuff not shown that you should sort of, all right, Kira, you want to take that one? Kira, you're muted. Now you're not.
109.5.
Good, and probably just a little less because of the 2 lone pairs. Max?
I know we've kind of gotten in the habit of when we see a diagram like in 122, we assume what isn't shown is H's. Is that just for carbons?
That's pretty much just for carbons, yeah. If it's anything else, you'd want to show the H's. So good point. Bond line structure pretty much assumes you're only talking about carbons. The hydrogen's not shown off carbons. So it would kind of be illegal to expect there to be any hydrogens there. Good question. All right. Hybridization. So remember, something could be sp, sp2, sp3. I know people are like, I've forgotten that completely. So why don't we just quickly review what's the hybridization of the carbon I'm pointing to here? Yun?
sp2.
Good. So you count the number of groups, and that's 3. A double bond or a lone pair counts as a group, and if there are 3 of them, 1 part S, 2 parts P. Let's try the hybridization here around this carbon. Max says sp3. That's correct. And what about?
That's SP.
Yeah, that's sp3 because it's got 4 groups. How about around this carbon? sp2. How about if we had a triple bond? Nobody's got a triple bond anywhere. What if there were a carbon with a triple bond and then another thing on its other side? What would the hybridization of that carbon be? Hyun? SP, yep. Okay, so that's a quick view of, review. Yeah.
I forgot if lone pairs count towards hybridization.
Lone pairs do count towards hybridization, so let's find, it's rare. You really can't do that with a carbon, but we can actually talk about the hybridization of that oxygen. It's got a double bond and 2 lone pairs, so technically its hybridization is
sp2.
sp2 because it's got 3 groups around it. This might be a better one to talk about the hybridization of. It's
sp3.
sp3 because it's got 4 groups. 2 of them are invisible lone pairs. Good. All right. I think that's a nice quick review of that. Then we've got bond line shapes, structures. We've been using these since we learned them, so I think we've been reviewing those pretty well. I would anticipate that you feel pretty good about that. Like there's a carbon here and then just a bromine. And Max's question about when you show hydrogens occasionally, they'll have to show this hydrogen because if they don't, it means, it's a CH3 there.
But like off this O, we're assuming those.
Off that O, there's just lone pairs. Good. Can anyone remember the name of this type of structure if it's a C double bond H like this? Oh, I know it's been a while since we've done that. Aldehyde is correct. It would be a ketone if there were a carbon here, but an aldehyde otherwise. Yeah. And if it were an OH instead of an aldehyde or a ketone, what would it be? If this were carboxylic acid. Yep. All right.
You have to have those memorized.
I think it'd be handy. There might be a question, and we'll see some more coming up. So here's the functional group one. Who wants to take that functional group on right there?
Oh, F.
Peter?
Amide?
Yeah, I think it turns out this one's all complex. I probably wouldn't give you an amide, but I think a C double bond O with an N beside it is an amide. If this N weren't here, let me just kind of try to cover it up. What would this C double bond O be then? Or, yeah, basically it would be this guy, which is a ketone, alkene, and this is an amide.
Wait, what's an ether?
Yeah, can anyone tell what an ether is?
Yeah, I was saying ether or.
So ROR, so carbon, oxygen, carbon is an ether.
Whoever
carbon,
said that,
is it just a single bond?
It's got to be a single bond oxygen in the middle.
whoever said ether or is like.
I think I accidentally invented that, I think. But I don't want to steal it if someone else did. All right, this one is talking about isomers and whether something's an isomer or not. So, like, are A and B isomers or are they just the same thing?
Same thing.
Yeah, they turn out to be just the same thing because of rotation around a bond. What about in C? What about the first one and the second one? Are they isomers or are they the same thing? Those are isomers. And one way to tell now that we know naming is they're actually named differently. So one's a 2-chloropropane, the other's 1-chloropropane. Whereas up here, these are both 1,2-dibromoethane, no matter which one. So think about the naming, and then this becomes relatively easy. So I think we're probably pretty good on isomers, so I'm going to keep going. Then we get to boiling point. Suggest a reason for the difference in boiling point between these. This one over here looks a little higher. Yet they seem to be isomers because there's 3 carbons and 3 carbons on either side. So what would make this one be a little bit higher, Max?
Surface area.
Probably surface area. You could say if they're longer, less branches. Generally, more branches make it for a lower boiling point. Let's see, the one on the left has 49, but the one on the right's only 3, and yet they're both isomers of one another. Why is this one so much higher? Marcel, thank you.
The first one has hydrogen bonding, which makes the boiling point higher
Nice.
than the second one.
Yeah, what does the second one have?
Just London dispersion forces.
Yeah, and probably maybe a little
dipole.
dipole because it's polar because of the nitrogen. All right, good answer there. And then the last one looks like it's going to be similar to the one before. Why is this one so much higher, Kira?
The hydrogen, the OH with a unshared pair of electrons bonded to the OH allows for hydrogen bonding.
Woo-hoo. Yeah, good answer. And then this guy's going to be dipole. Excellent. Good job.
Add an ether.
Sorry, let me back up. Yeah, good. Thank you. That's an ether. And here's an alcohol. Yeah, ether, alcohol. All right. And we have slipped into Chapter 2, so we're starting to review our Chapter 2 material here. Here again, we've got more boiling point stuff. Here they're asking why do they not differ much. So they... again, can someone move the pointer for me? I got lost in the corner there. I don't know why that happens to me.
I don't see it.
There you go. What's the point? Oh, let's take a quick look at 2.3. Of these 3, which one is which of the 3 is non-polar is the question. Which are non-polar? Let's see. Let's go to Marcel.
The third one, because the dipoles on the chlorines cancel out.
Nice. Yeah, good job. I'm going to shout out a question to Robin. Robin, I can't see you. Can you hear us or not?
Oh, I'm not sure. By me, the video is appearing, but yes, I'm definitely here, yeah.
All right, great. So, yeah, we got that fuzzy image of you again. You may have to text us if you have any questions because I can't see you or the class can't see you. All right, let's keep rolling. I think you guys got the polar stuff. All right, here's some water solubility thing. What about why would one be... that
was my bad.
That's okay. Propyl glycol, the one on the left, is miscible in water, which means totally soluble in water, whereas the one on the right has a fairly low solubility. Anyone want to address why the one on the right has low solubility, or why the one on the left is totally miscible? Miscible means totally soluble. Margaret?
I think it just has to do with the number of OH groups that are on the molecule. So the more OH groups there are, the more opportunities for hydrogen bonding there are, and that way it can interact with water more.
Good. When we see an OH, we generally think soluble in water, but a nonpolar end like this on butanol, this part is going to make it nonpolar and less likely to dissolve. So you're right, more hydroxyl groups, OHs, will make it more soluble, more hydrogen bonding possible. Good.
Can we go back and just do the bottom one?
Yeah, sure. I can do any of these. So the bottom one says butanoic acid. The one on the left is miscible in water, but the one on the right is not. What would be the reason?
Yeah, okay.
See it? Yeah, it's got the OH, so it's going to be the one on the right slightly polar with the stuff in the middle, but maybe a lot of the other carbons are going to knock that out. But the hydrogen bonding option there is going to make it more water soluble.
Why isn't butanol very soluble? Because it seems like it.
Okay, so the way solubility works, I'm going to chop off carbons and pretend like it's just one carbon. Methanol, extremely soluble. Now 2 carbons alcohol. Ethanol, very soluble. Propanol starts getting less soluble, and then butanol is on the low because those carbons out there are like a fat. They're like an oil. They're non-polar. Yeah. And the more you get, so it happens on the quick side. Methanol and ethanol extremely soluble, but once you pass that point, at some point the solubility starts dropping off fast. So they're asking for conjugate acids of these things. Who wants to do?
Not a fan.
Some of these would, all right, let's take maybe just the first one then. What's the conjugate acid of this? Woo, that's a tough one. See who wants it. Margaret's being brave. Go for it, Margaret.
Okay, so the conjugate acid is just sticking on a hydrogen somewhere, right? So wouldn't you stick that on the sulfur?
Yeah,
somewhere?
you would. Yeah, so what, and then the formula is just CH3, with a plus charge, right? When you're done. Yeah, and that's, this thing is pretty stable, so that's not going to be it's not going to be easy to put that proton on there, but that's what it would be. How about if you had to do the conjugate base of this thing?
Robin.
What?
We can see Robin.
Hey, we can see Robin. Cheer!
Yay.
Woo! Nice to see you, Robin. Welcome to class. Robin, do you know what the conjugate base of this thing is that we're pointing to?
The conjugate base would be CH3S minus.
Yeah, good job. All right, so we got that.
Really good.
So I think that's pretty good on those. Let's keep rolling. Oh yeah, here's where we get the pKa. Yuck. Who remembers what the deal is with pKa? And so it says approximate pKa is something is 49, and the pKa of something else is 16. Which is the stronger acid? It's been so long. Can anyone help us remember what the heck P means in terms of Ka? Kira, thanks.
Is someone cheering?
Someone at some school is happy about
Most
pKa.
people they're happy they're out of school. So.
Okay. Well, P is a mathematical function of a negative log base 10 of K.
Nice. So which one is the stronger acid? Something with a pKa of 49 or 16?
16? No, 49.
Yeah. Turns out the 16 means it's like 10 to the negative 16th, which is a Ka. That's pretty weak, but 10 to the negative 49th is even weaker. So, yeah, the 16, the lower the pKa, the stronger the acid, because it's like a lower negative exponent on the Ka. So given that means this acid that I'm pointing to,
That was my bad.
This acid is stronger than this acid. So is this equilibrium shifted to the right? Oops, that's the other way. Shifted to the right or to the left? Given that the acid that's being pointed to is the stronger acid, which way would equilibrium be shifted? Towards it or away from it? Kira, I think you're right, but I can't tell what right and left is once it hits the screen. So yell out left or right for me.
Left?
Left, correct. Good. So the stronger acid is going to drive the reaction away from the direction of the other one. Let's look at 15. It says the pKa of acetic acid, and they give you the formula, is 4.8. So, okay. Then using the concept of inductive effects. Oh, I like inductive effects. Explain why carboxylic acid group of amoxicillin, which has a pKa of 2.4, meaning this is a stronger acid, is more acidic than acetic acid. So we're going to look down here like this. Here's the COOH that's analogous to the COOH of acetic acid. And let me move my pointer just a little bit. Why is this a little bit stronger of an acid by the inductive effect? Who remembers the inductive effect?
Okay, wait.
All right, Yun, or let's go Ramsey.
Okay, so when you have electronegative elements bonded to a carbon and there's a hydrogen, that basically shifts electron cloud density away from the hydrogen bond.
Yeah, which ones are you talking about, though? I agree.
So, nitrogen, oxygen, halogens.
Yeah, and in this molecule, which ones?
Sorry, it would be the oxygens, the two oxygens bonded.
So the problem with that is this also has two oxygens bonded to the carbon. So you're comparing acetic acid, which has the exact same thing. That's okay. So why would this group be a little more acidic by the inductive effect? Do you want to?
Nitrogen.
Yeah, good. The nitrogen here is only one atom over from this carbon, which is one atom over for that. So it's sucking electron density towards it. You know, the sulfur's probably a little too far away to do that, but the nitrogen, and if we had something like a fluorine up in here, that would certainly help, or anything else. So that's a little bit of inductive effect there going on.
I somehow saw a chlorine in that.
Oh, I got you. Yeah. And a chlorine would certainly help with that process. Okay, let's keep going. Equilibrium, reaction rates and mechanisms. Oh, yeah. Do you remember that bond cleavage stuff? It either can be homolytic or heterolytic cleavage in terms of breaking. Always makes Young Hyun laugh.
Young Hyun laughed there. Mr. Spraggan said you guys be a foursome. Young Hyun found that to be hilarious.
Okay, yeah. Gotcha. So, does this look like... Is this homolytic or heterolytic cleavage, given that we see a lone single electron here and a lone single electron there? What's the implication?
In all seriousness, I forgot what cleavage, like bond cleavage.
Yeah, it means breaking the bond, and whether you break it off so that you split the electron pair in half, that's homolytic, or whether you split it and the electron pair stays in one and goes away.
Okay. Right.
So this is an example of homolytic cleavage, which creates what's called a free radical. With a lone pair electron there, or lone electron not pair. Same thing below. This is a lone electron and a lone electron there.
Crazy reactive.
So very, very reactive, and this is homolytic cleavage. Okay.
Mr. Walker?
Yeah, please. Go ahead, Peter.
On the test, would you ask, is this homolytic or heterolytic, or would you say, what's the process of bond cleavage called?
Good question. I don't know, because what I'm saying I'm doing is I'm actually taking questions from the book. So this would be an example of a question from the book. If I thought the question were unclear, I might add the words. But I think just maybe if we're talking about bond cleavage, remember that there's two types, homolytic and heterolytic. Good question. I won't modify the questions too much from, again, these are potential questions for our test. So as you guys, hopefully you'll have a little bit of time to review over the weekend. If you bring questions up in class on Monday, that'd be great for me too. Let's see if we can find a good one along in here. There's a lot here. Let's take one and see if we can understand what 235 is saying. It says hydrogen peroxide, and they give us the formula, reacts with a proton to give a conjugate acid that undergoes heterolytic oxygen-oxygen bond cleavage. So this bond is going to break in a heterolytic way. So both electrons are going to go in one direction and not split. What is the second product? So a hydrogen comes in, attacks, and forms water. It tells you it forms water, and then what's the other product? So you guys should be able to figure that out. Take a second to imagine a hydrogen coming in, forming water, heterolytic cleavage of the OO bond. What would be the secondary product? Raise your hand once you get an answer. I have an answer. Robin's got an answer. Ramsey's got an answer. Summer, let's call on you, please.
Is it OH minus?
Yeah, nice. Good. All right, any questions about that? All right, let's keep rolling.
Mr. Walker, can I run and get my computer charger because I don't have it in the room and my
yeah,
computer's
of course.
dying.
Thanks for checking in on us. So we're into chapter 3, and I'm looking. I've got just a little bit more than 15 minutes. Oh, can I pull you guys a little closer, and that way I might be able to tighten the screen up. Peter, go ahead.
On the previous question, wouldn't heterolytic cleavage yield OH minus and OH plus?
Has a proton coming in though?
So yeah, Ramsey's helping with that one. It has the proton coming in. Actually, let me see what you're saying here.
And the proton reacts with the OH minus to form water. And wouldn't the other product be OH plus?
Oh, actually, you may have a good point there.
Weird.
Yeah, let me draw my dots out a little more carefully. I think you may be right. Yeah, you are right. It is OH plus because, sorry I missed that. When the H plus comes in, it's going to react with the oxygen that's got both electrons for it because the hydrogen has none, and that forms neutral water. And the other reason that we know you're correct there, Peter, and good job, thanks for correcting us, is if an H plus comes in to a neutral thing, then we have to have a product that has a plus charge too, and that's another reason you're right. So that's a really unstable with 2 lone pairs, an H, and a total of a plus charge. Excellent job. Thank you. Yes, you're correct, and I way too quickly said that Summer was right. Thank you for that one. Extra credit.
Micro points.
All right, we're into chapter 3. 3 gets into all our structural formulas, and again, I think we hopefully spent enough time on this and kept going that you guys feel pretty confident. So some of this stuff has to do with, like how many, do you remember the formula, like if an alkane has 31 carbons, how many hydrogens would it have? What was the trick there? Yeah, Robin?
Be 2x plus 2, so I think 64.
Yeah, good job. All right. And then this thing about allele groups, what's the common name? I'm never going to ask you the common names. Anyone want to try to give me the systematic IUPAC name for the one I'm pointing to? Let's see. I'd like to spread. Kira, thanks.
Is it a 1-methyl-propyl?
Boom! Nice job. Good. Yep. Excellent.
Wait,
right beside. Do you understand, Keith?
Yeah, I didn't realize there were alkyl groups.
Yeah. So it's like an R group stuck onto a long chain. So like this is a 2-methyl-propyl because this part right here would be stuck to a much longer chain. It's not shown. Okay, good. Hopefully that's a quick review of that. And again, I'm not going to expect you to know common names like isobutyl or butyl or any weird things like that. You'll always get systematic naming. So this is more naming of side groups. I think you guys would be totally fine with all these. Yep, I think those are all pretty good. Sometimes structures are written with weird bends and twists in them, and we got to learn to ignore that. Like, let's all try to name D, realizing that we always, got to be careful. So everybody come up with a name for D, and then we'll see if we agree with you. Let's see, Max?
3-methyl-octane.
3-methyl-octane. I think it's heptane. I think you counted one extra oxygen by accident, or one extra carbon, yeah.
Yeah, you're right.
Yep. All right, so I think we're good on that. This one looks fun. Let's do this one. Try to name this one. Wow, it's ridiculously long. 1, 2, 3, 4, 5. Okay, this will be fun. We can name this. It's not a number of carbons we don't know. So we're going to need a parentheses in there at some point. Who wants to give it a shot? Robin, take it away.
Actually, I didn't have in mind a parentheses, but I was actually thinking 5-pentaldecane. Would that be possible?
Oh, I got
it. It would be, but notice off your pentyl. Oh, I see. But if your pentyl group were coming off, that implies that it comes off as a nice straight line of 5. But do you see how actually you've got a straight line of 3 and then a branch of 2 off that? Do you see it? You want to try again?
Yeah.
Okay, Yun, do you want to help him? Or let Robin correct himself then. Go, Robin.
I guess then it would be. This is just to try 5-methyl and then parentheses 1,1,1-diether. And then parentheses close decane, if that makes sense.
Yeah, you got a few problems with that one. So Hyun, bail him out.
Wouldn't it be 5 and then parentheses 1 ethyl close parentheses propyl?
No, I mean parentheses after the propyl.
After the propyl and then decane.
Yeah. So 1 parentheses. No, sorry, 5 parentheses, 1 ethyl propyl, close parentheses, decane. Wow, that's a tough one. Yeah, that was very tricky. But yeah, so just make sure you see that propyl group kind of bending off down here like this, and then this is the side chain off that one. Woo! Nice. We got about, question. Peter.
Did we ever get into, groups with double bonds?
like off of a side chain.
Yeah.
I don't think we're going to run in. No, we never really saw any yet. What we always tried to do was try to keep the double bond within the longest chain. So I think if you saw something weird with a double bond out there, you would try to name it so the double bond fell within the link. Then your branching groups would be, propyls and, does that make sense? Yeah.
Yeah.
I think that's the best way around that. And then I feel like
there's ever going to be. Sorry. Is there any conditions where we have like more than one branch in a subgroup? You know what I mean?
Yeah. I guess you could, if for a super long molecule like a decane, you might be able to sneak in another one like the one we just did. You might be able to sneak one in right off here, like as long as the number of carbons didn't get too long, because otherwise that becomes your longest chain. Yeah, and then I guess you get into some real complexities about which you'd want to probably go low number and the ordering. I wouldn't give you that. Two, there are no questions in the back of the book that have that, so it's not going to be on the exam. But as an intellectual question, I think it'd be a fun thing to try to chase down exactly where it all ends out. I don't think we have to worry about that.
Yeah. Okay. Never mind. Don't worry about it.
Yeah. So here's some examples where they go the other way around. I think you'd find this easier, like if you were given. Sorry, I'm laughing because Max is whispering that Margaret's eating in class. I don't have a real problem with that. I know, right? Let's see. So if you were given the name, I think this would be easier than going the other way. You're probably less likely to make mistakes that way. Also, if you want to have a party on a Friday night, try one of these like this. There are 9 isomeric C7H16 compounds. Which isomers have a single methyl group as a branch? Or you can come up with your own questions that are much more complicated and difficult to have more fun with those. So anyway, I think those, I'm just pointing them out. They'd be fun, good time to play with. I think you guys are probably fine with all that. Also keeping an eye on the clock. If we've talked about primary, secondary, or quaternary carbons, we've been doing that pretty much most of the year, so I think we'd be good shape most of the semester, sorry. Cycloalkanes, remember they're out there. Can someone grab my pointer? I've lost the ability to move it, thanks.
Nope.
Yeah, there it is, thank you. I don't know why it gets tucked over there, like 1,1-dimethyl cyclobutane, we could easily come up with what that is, or cyclooctane. Oh, this is something that bothers you guys. You guys have trouble with this, so let's look at any of these
gross.
These confirmation things. So for some reason, this seems to bother people. Let's try both 27 and 28 and write down an answer. So draw the Newman projections. Remember, that's like the circle where you're looking down the bond and you see certain things in the front and in the back. And I'll write the answers on our board and we'll switch over. Draw the Newman projections of the 2 staggered conformations of 2-methylbutane. So obviously you have to first draw what that is in non-Newman projection formula, and then draw that thing with the 3 spokes coming out in the front and then the back, and do 2 staggered positions. That's 327. When you're done with that, let's do 328, which is and this is down bonds 2 and 3. 28 is going to say 2,2-dimethylpentane. And then for that one, you're going to want to look down bonds 3 and 4. So I feel like sometimes you guys have a little trouble with that one. So give it a shot for 27 and 28. I'll write up an answer on the board. Anybody at Murray should just ignore what I'm doing. And then we'll project the camera over to see how that looks. So if you can, people at Murray, try to ignore what I'm doing up here.
Close enough.
Wow, that was annoying.
Do they ask in the question which is more stable, or do they just ask to draw
Which
the
is
two?
more stable?
They do ask that?
Yes.
I missed my first 2 shots.
You're the basketball player.
I am a basketball player.
Different game too?
Yeah, I thought I was gonna miss the class, but they moved our game back.
Aaron, have you done these, you punk? You lie! Do them on a piece of paper. You do need to practice these.
Yeah. You know, to kind of piece of paper. No. Okay.
You do
I didn't remember how to do them. That was I remember like
Yeah,
what I
see,
remember the
I
circle like the peace symbol thing, but I don't really.
I didn't even remember like how to properly draw the peace symbol thing. So I remember on my test I tried drawing like the regular like just like the peace symbol without any of the lines coming out of my draw because like that's not even it on my test or something.
Wait, what?
I just think I get it now. I had some idea. I don't know if we like read it in the textbook, but there's something where it's like called like ellipsed or something weird, where they're all like next to each other, and that was kind of messing me up. You know what I'm talking about?
This is the one
Like,
with the
where
steric hindrance, right?
Yeah,
I think it is the one with the steric hindrance.
Yeah.
The steric hindrance joke.
On the right's more stable. You want me to give you a switch?
Yeah, let's switch them up. So I'm hoping that it gave you guys enough time. I had 2 of my 3 could you do this, Ramsey, or not? People are struggling with this, so.
I think I got it, but I'm not 100%.
So let's look at the first one. Back up a little bit.
Yeah, I got this.
Okay. Oh, nice. 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 Okay, so our structure is we've got 2-methylbutane. And we need to look down carbons 2 and 3, which are pointed out here. So you got to imagine that carbon 2 is sitting right there, and carbon 3 is back behind it. The carbons that then you want to say to yourself, what's attached to carbon number 2 here is a methyl group, and a hydrogen. So out in the front, methyl, hydrogen. Then behind it, there's a carbon, and again, we don't tend to show this, but there's a hydrogen, and a CH3. So in the back, I should have a hydrogen, and a CH3. So again, on your molecule, you may want to draw it out and be more careful and say, what's around carbon number 2? What's around carbon number 3? And just make sure they're showing up. Like this is a CH3, etc. And then, let's take the back and only move the back and never move the front. So over here, notice that my front has stayed positionally, and then I just moved my methyl group down to here. This is bad because now these groups are too close in space, whereas you'd rather have them a little further apart. So it's staggered, but this is the most stable. Is this coming back to people?
Yeah.
Class, is this coming back to you? I'm looking at you. I need nods, heads. Okay. All right, now let's look at 28. Here, and we've got a couple minutes still. Now we're looking down bonds 3 and 4, right? So here's carbon number 2, which has got this, methyl groups all around it. Carbon number 3, what else does it have that's not shown? It's got a hydrogen and a hydrogen. Of course, there's one down here that I'm not. And then number 4 has a hydrogen, and then a methyl group. So what's the third group off this carbon number 3 is a CH3 3 times. So that's called a T-butyl group. Then it's got an H, an H and an H. So the front group's off carbon number 3. And then in the back, off carbon number 4, I've got an H and H and a methyl, H methyl. Then only rotate the back and figure out where it could be the most stable. I initially made the mistake of pulling it down here, and that's wrong because it's exactly the same distance from that. So I need to pull it all the way over here so it's as far apart from the T-butyl group as possible. Any questions about that?
Wait, I'm sorry, where does the name staggered come in? Is staggered just...
Staggered is like this. Eclipsed would be if you turn them so they were all lined up like exactly on top of one another. So like eclipsed, I don't know how much room I have. Eclipse would be turning at 60 degrees.
So is eclipse always going to be...
Always even higher energy, staggered is the best you can get, and then within staggered, sometimes one position is better than another.
Wait, but
What?
Eclipse is always worse.
Eclipse is always worse because they're totally lined up straight down the bond.
And when would that actually happen?
But wait.
Well, remember there's free rotation, so it actually is going to go through an eclipse as it goes from one staggered position to another.
The eclipse one on the right?
All of these are eclipsed position. Oh, sorry, all of these are staggered. Sorry,
Okay,
I'm not showing
us. Like, take the 3 lines coming up between the longer lines and just rotate them so that they line up. They line
Got it.
All right, Peter, you have a question?
That's where I was confused.
Yeah, would it be possible for you to send all the PowerPoints to me by email? Because the one on EPGY is really laggy on my computer.
Yeah, what are the PowerPoints? The ones I'm doing right now?
Like all of them.
Like the video ones.
The video ones. So yeah, I can send PowerPoints. And that might be a fast way to study, just zipping through the PowerPoints real quickly. Is that what you're looking for?
You can't access.
Yeah. Do you want it for like chapters 1 through 7?
Yeah, all of them.
Send them to all.
So I would send them to the whole class then, if that's.
Because it's just in general.
Yeah. Now those PowerPoints are like, they have some big file things, so I don't know if your email will get overwhelmed, but I'll do my best. So I'll send. Here's the annoying thing: I may have to send them. If I can send them all at once, I'll do it. But if I have to send them like chapter 1, chapter 2, chapter 3, if it gets annoying, just realize that was a request. You can always just delete them if you don't want them. Send to class. Yeah, I will do that.
Share it by Google Drive.
I'll write that down. Share by Google Drive. All right, so maybe that's a faster way to do it.
You can
Thanks,
share
Peter.
all of it at once. Yeah.
All right, thanks. All at once. All right, thanks for the tech advice. We have 0 time, and we got a pretty good ways through chapters 1, 2, 3. We didn't have a whole lot left in chapter 3 before we hit chapter 4, and that was sort of my goal, is to get at least through 1, 2, 3. So on Monday we'll pick up with the end of 3 and then do 4, 5, 6, 7, and hopefully, since those are closer units in time, they may not take as much time to review. We'll see. Have a good weekend. Good luck on studying for all your exams. And Peter, this is the last time we'll see you, right? Oh, everybody say goodbye to Peter. He's not going to be in class on Monday. Peter, loved working with you.
Oh, wait, we need to switch.
Oh, wait, we got to switch back. Oh, Max switches back. Peter, it's good working with you. We're all waving goodbye.
Yeah, it was a great class, guys.
It was a pleasure having you.
All right, thank you, Peter.
What's that?
Yeah, I know. Everybody take care.
This is your pen.
Oh, it's kind of sad, Mr. Walker. It's kind of sad.
Feel better, and thanks, extra credit.
Mr. Walker, I'm kind of sad now. Like,
I know,
I just
right?
realized it's coming to an end.
Hey, playing the height game was fun.
I'm going to miss you, big guy.
Yeah, I'm going to miss you too.
See you guys.
Thank you very much, Mr. Walker.
Bye-bye. See you, Robin.
Have a great weekend.
Thanks, you too.
Whose is it?